Welcome to your online laboratory safety practicum. This laboratory safety practicum will replace the standard in person laboratory safety practicum. In today's online practical, we'll be going over some of the key essential features of laboratory safety. That includes building safety, laboratory signage, engineering controls, administrative controls, personal protective equipment, or better known as PPE, standard operating procedures, also known as SOPs, waste handling, training programs, accident and incident reporting. So let's begin the fun process. Now, before we enter the laboratory space, let's discuss some general building safety practices and procedures. An AED can be a valuable life saving piece of equipment. In any building that there is a laboratory hazard, an AED will be located. Typically, that AED is located on the first floor near the restrooms. But please always check where your AED is located. Be familiar with these locations because, in the event of emergency, you may need to find it quickly and efficiently. Advanced training for AED usage can be provided to you by the Rec and Wellness Center through their AED and first aid and CPR classes. I encourage you to take advantage of this because it's an awesome resource available to you. AEDs are easy to use. The instructions within the unit will walk you through when you go to use them. Wherever there is a laboratory hazard, first aid equipment will be available for your use. Typically, that first aid equipment is found in a common space or within your lab. Please always check to make sure first aid equipment is easily accessible and that you know what is available within your first aid kit. First aid kits are maintained by the Environmental Health and Safety Department, so if you need refills, please put in a request to us. Also, please note if you're using first aid equipment, that means you've probably had a laboratory incident or accident. Feel free to use it, but also make sure that your primary investigator or your PI is informed that you have used the first aid equipment. Let's talk about fire extinguishers. At UCF, as you can see, each fire extinguisher usually is located within a pull box. Those pull boxes are actually not alarmed, so if you were to open one and remove the fire extinguisher, an alarm would not sound. In the event that you're using a fire extinguisher, most likely you have a fire. Please make sure that in the event of a fire, you call 911. If for some reason you call 911 and you don't get UCF dispatch because we are in the greater Orlando area, just tell the dispatcher that you are at UCF and would like to speak to UCF Police Department so that way we can have the appropriate fire department respond. Now, please note most fire extinguishers for laboratory usage are small 5 or 10-pound extinguishers located within 50 to 75 feet of the room. These fire extinguishers, when they are used, will not provide more than 5 to 10 seconds worth of power. So you are to really only use these for small office fires or trash can fires. Anything other than a trash can fire, please follow appropriate procedures to evacuate the space and pull any necessary alarms on your way out. We want to make sure everyone is informed to evacuate the area. Fire extinguishers do need training to use them. The technique that's usually used is the pass. We do have training provided to you from our fire safety crew. So please, if you'd like additional training, reach out to the EHS department so that way we can offer that to you. In the event of an emergency or fire, and you do have to evacuate the space, please make sure that you activate one of the pull stations to indicate that the alarm is sounding. We want to make sure that everyone is informed that there isn't a fire or an evacuation, and these pull stations will do that. A visible and auditory alarm will sound throughout the building, indicating that all personnel should leave. Now, in the event of a fire, we definitely don't want to take an elevator because of the fact of an elevator in a lot of ways will act as a conventional oven in the event you get stuck inside of it. So we don't want you to become a roasted turkey. So please do not use an elevator. Also note when the fire department arrives on the scene, they may shut the power off to the building for their own safety, in which the elevators would stop working as well. So being in an elevator during a fire is not a great situation. So please use stairs and follow all emergency signage on your way out. Now, each lab has their own evacuation plan, so please ask your laboratory manager or PI to be informed as to what that is and be properly trained on what those protocols entail. Most laboratories also have an evacuation plan posted on the back of the door on your way out. It is meant to be detachable, so that way you can take it with you in the event of an emergency. In the event you do have to leave a building because of a fire, please make sure that you're traveling at least 400 feet upwind of whatever direction that is, and you can always look at a tree or a flag to indicate what direction the wind is blowing. I always recommend making sure you have a good spatial awareness as you evacuate because of the fact of you always want to move farthest away from the hazards as possible. In the event of a power failure, there will be emergency lighting for the building. The lighting will be provided through actual lamps and your overhead lighting, as well as emergency lights and signage. That signage will usually indicate to say exit or a direction associated with where an exit is. In the event that there is a power failure, please be aware that these lights will engage and you'll be able to follow to the safest route. Please always follow the signage so that way you find the safest, most efficient way out of the building. In newer buildings, an area of refuge may be present. An area of refuge is a specific area that is designed to be the most structurally sound spot of the building. So, in the event of a fire or some type of structural failure to the building, this area is the area that will last the longest. Not all buildings have area of refuge, but in the event that a building does have it, it is a good place to huddle because first responders will look here first before searching other areas. So please be advised as to whether or not your building has this unique structure, and if it does, in the event that you cannot safely exit the building, then please use this as your rally point. But I always recommend if you can find a way out of a building, try to use that first. Some buildings also have emergency phones. Also, laboratories typically have an emergency line as well. These phones are used in the event that your cell phone may not work inside of a building because of how it's built. You might not get signal. So, an emergency phone might be a great option in the event of an emergency for you to be able to call out of that space. These phones typically connect directly to the emergency response center and will allow you to get in touch with the dispatcher readily and quickly. Emergency showers and eye washes are there for emergency use to make sure that if you're exposed to any type of chemical and you get it on your body or in your eye, that we can make sure that it gets off so that we can minimize the hazard associated with that chemical. In the event you have to use an emergency shower or eye wash, it's within moments of exiting the lab or it's somewhere within the lab. When you use an emergency shower, you're going to pull a rod, and that rod is going to dispense 15 gallons per minute of water across your body. Uh, that will basically be like taking a cold shower. And the same thing is true with the emergency eye wash. It's about 5 gallons per minutes. In the event that you have to use the emergency eye wash, you're most likely going to have someone hold your eyes open for those 15 minutes because your eyes will start to swell and close. But we need to make sure that you are submerged for at least 15 minutes so that way we can reduce your exposure to whatever that hazardous chemical is. Be aware that not all buildings have floor drains. Some of our older buildings lack that, and water will be spread across the entire floor. In the event you need to use an emergency shower or eye wash, we definitely want you to use it, but our PPE and good laboratory practices will prevent the usage of this for the most part. So if you don't have to take a cold shower, follow proper safety practices, and you might not ever have to use this. Here at UCF, before you enter a lab, we have signage that indicates what hazards are present within the space. We also have signage that indicates what are university policy. So, if you look at a laboratory safety sign before you enter, there will be several green boxes indicated at the top left side of the sign. Those boxes indicate standard operating procedures for lab safety, such as you must wear a lab coat, you must have closed-toed shoes, you cannot eat or drink within a laboratory, and you must wear the appropriate lab safety goggles. It also indicates hazards. Hazards could be corrosive materials, flammable solvents. It also gives us an indication of our fire diamond. So we have to make sure that our first responders are well informed and we follow the fire code. So that's the reason why we have our NFPA fire diamond. That fire diamond is broken into four components. On the left-hand side corner, it is a blue box. That blue box indicates a health hazard. So think of health as mainly water because the effect of we are mainly water, so as a health hazard to us. That scale goes from 0 to 4, 4 being the most extreme, 0 being the least. The top box in the fire diamond is a red box. That's indication of how flammable something is. Same principle, 4 being the most extreme, 0 being the least. On the right-hand side of the box is a yellow box, and that is an indication of reactivity, how unstable that product is going to be, 4 being the most extreme, 0 being the least. And in the white box, it's an indication of special hazard class. Typically at UCF, you're going to see two hazard class. Those are our OXs. That means it is an oxidizer. So if it's exposed to oxygen, it's going to ignite or flame up more easily. Or if it reacts to water, it'll be a W with a line through, which means if you put water on it, it's going to create a volatile reaction. So we want to make sure that we minimize those hazards that are associated with it. Lab hazard signs also indicate who is the primary contact and who is the secondary contact in the event you can't get in touch with the primary. It also has great information like your work control number. So if you need to put in a facility maintenance request, or if you need to get in touch with EHS, our number is listed right there as well. We also have some secondary hazard information listed on the side and what building number is associated with that sign. Always make sure that you read your hazard signs before entering a space so that way you're aware and understand the hazards before entering. Now that we've covered building safety and laboratory signage, let's go ahead and enter the lab. But wait, the lab's locked. The lab's going to be locked for security reasons. We want to make sure that we have authorized personnel always within the lab. If for some reason you enter a laboratory space and you notice someone is in that space that you're unfamiliar with or shouldn't be there, and if you're comfortable approaching them, please do so and ask questions as to why are they there and who are they. If you are not comfortable with that, please go see your supervisor or your PI and let them know so that way we can make sure that the lab stays a secure location and that only authorized people are within the lab. So let's talk about engineering controls now. Engineering controls are physical barriers that are designed to minimize or prevent your exposure to a hazard. I would also like to remind you at this point to look at your check sheet and check off any boxes that are indicated for building safety and laboratory signage. At this point, we've covered all of that material, so go ahead and check those boxes. But if you have additional questions, please reach out to the Environmental Health and Safety Department and we'll be glad to answer those. One engineering control that's commonly found inside of a laboratory area is a fume hood. Fume hoods take obnoxious vapors or hazardous vapors or fumes and exhaust them to the exterior of the building. Fume hoods are appropriate for chemical use. At UCF, we require you to use all hazardous chemicals in, inside of a fume hood. That way, you don't have any exposure to hazardous vapors or fumes. Typically, fume hoods are inspected biannually, so we certify them twice a year, and we make sure that the airflow across the sash and into the unit is between 80 to 120 feet per minute. Fume hoods, again, are used for hazardous chemicals. We wouldn't want to use biological materials inside of a fume hood because the fact of we would then exhaust those pathogens into the surrounding environment, which for anybody on the outside of the building, that probably wouldn't be the best situation for them. We want to maintain everyone's health and safety. So when you fume hood, please make sure that you're only using chemicals within it. Also, fume hoods typically have chemical storage underneath fume hood. Chemical storage can consist of one of two things. It could have a flammable cabinet in which that cabinet is self-sealing and rated for at least a 2-hour burn, or we could have a corrosive cabinet in which it's lined with special material that is impervious to corrosive materials, and it also is connected to the exhaust system to exhaust hazardous vapors as they build up within the cabinet. If you are using either one of these cabinets, please make sure that they are properly labeled with the appropriate signage for flammables. UCF does have a chemical policy that allows us to put acids and bases stored together inside of a fume hood as long as they are separated by a secondary containment. There is one caveat to that rule, and that is with nitric acid. Nitric acid has to be segregated into its own secondary containment. So again, if you are using the chemical storage, make sure that the appropriate signage is on the outside of the cabinet. And if you're going to use a fume hood, make sure the sash is set to the appropriate height and make sure that you're working with chemicals at least 6 inches inside the cabinet. So that way all of the vapors will be exhausted to the exterior. A biosafety cabinet, or known as a BSC, is a device that is used to work with infectious materials. It's an engineering control in which we are actually filtering the air through the unit into HEPA filters, and it will remove infectious materials and create a sterilized work environment for you to work on. Biosafety cabinets work by pulling air just like a fume hood across the sash and into the unit, but unlike a fume hood that draws the air towards the back, This actually draws it underneath the workspace and through the filtration system. Biosafety cabinets are inappropriate for chemical use because effective most biosafety cabinets filter some back into the workspace. So if we're working with a chemical that's creating hazardous vapors, we're eventually going to put that back into the lab, and we don't want to do that. However, we also don't really want to use hazardous chemicals inside of a biosafety cabinet because those chemicals could degrade the HEPA filter, which then reduce the effectiveness of the biosafety cabinet and preventing your exposure to infectious agents. So please, if you're going to work with chemicals inside of a biosafety cabinet, make sure that you've diluted those inside the fume hood first. Biosafety cabinets should only be used for infectious materials. So let's talk about some other engineering controls that are specific to laboratories. A ventilation system within a laboratory uses unrecirculated air. So we're constantly drawing air from the outside environment, conditioning that air, filtering it into the space, and then removing it. In a laboratory, you typically have about 8 to 10 air exchanges every single hour, whereas in your house or an office space, you're only going to maybe have one or two per day. So, in a lab, we're constantly doing air exchanges to make sure that we're reducing your exposure to any potential hazards within the space. If you notice within a laboratory, you usually have a unique floor. It's one unified material across the entire floor that has about a 4-inch lip that goes up the side of the wall. This is to make sure that no chemicals make it underneath or behind a structure and that we can easily clean them up in the event of a spill. Cabinets and furniture in a laboratory are specifically designed to be resistant to chemicals and resistant to flames. And so our tops are made out of impervious surfaces and it allows for easy cleanup. Within a laboratory, you'll also find a hand washing sink. This sink is one of the best engineering controls for making sure that you have removed any type of infectious material from your hands before leaving the space. It's also UCF policy that you wash your hands before exiting the space. I encourage you to follow the CDC guidelines for washing your hands with soap and water for at least 20 seconds. Within a laboratory, we also have fire control mechanisms, which we've already talked a little bit about some of those, such as alarms and emergency lighting, but you also have sprinkler heads inside of a laboratory. These sprinkler heads dispense water in the event of a fire. Some other engineering controls that may or may not be present within your laboratory are electrical shutoffs, cylinder restraints, or gas valve shutoffs. These really depend on whether or not these hazards are present within your laboratory. An electrical shutoff is used in the event someone is getting electrocuted. So you'd want to engage the electrical shutoff before providing first aid or CPR to the person. A gas shutoff would be used to shut off a gas leak. Say that one of your main bench tops have lost control of its shutoff valve. You'd go to the main gas shutoff, which is located typically outside the lab because we don't want you entering a hazardous space that's filled with gas, and shut that valve. A cylinder restraint is used to make sure that a cylinder stays upright and immobile from usage. Cylinder restraint on main campus is located just above center. There'll be a metal chain or strap that goes completely around that cylinder that locks it to a wall or an immovable object. And at Lake Nona, restraint is at the top and the bottom of the cylinder. The next section that we're going to discuss is administrative controls. So we've already talked about engineering controls and how we reduce your exposure to a physical hazard. Administrative controls are an additional way that we can do that. We can set specific procedures and practices in place that minimize your risk by your work practices. So let's talk about some of that. We've already discussed laboratory signs, but we haven't talked about UCF policies and procedures. We know that there's certain level of PPE that's required in the laboratory, but we also have specific practices you must follow. Those practices are outlined within the lab safety manual. A lab safety manual will be available to you in every single laboratory as well as online. If you go to the Environmental Health and Safety website and click under Laboratory Safety, you'll be able to find a digital copy of the laboratory manual. Within the laboratory manual, you'll keep your inspections and your standard operating procedures. As scientists, we develop good laboratory practices by being able to create repetitive and reproducible results. SOPs are one way that we're able to do that. If we can write down what we want to do and we are able to repeat the written work, then we're able to pass that work on for verification. I would encourage you to have an SOP for everything that you do within a laboratory. So if there isn't one, talk with your primary investigator or supervisor and see if you can write one. That'll be a good technical writing experience for you. Inspections will be done at a variety of different levels within your laboratory. Laboratory staff will have to take care of weekly and monthly inspections. The Environmental Health and Safety Department will come and do an audit once a year to make sure that a larger scale regulatory compliance are being met. And we will also provide you with additional training. Training opportunities will come up as annual refresher trainings or new training opportunities. As you're exposed to new hazards within the lab, new training requirements will be placed on you. Please do follow all training guidance and that you're staying current on your training. We don't want to prevent you from your laboratory activities, but we also need you to maintain good safety practices, and training is one way that we do that. The Environmental Health and Safety Department is here to assist you with all of your laboratory activities. We have experts across multiple subdisciplines, and our bread and butter is making sure that you stay safe and healthy. So please utilize our expertise and knowledge anytime. We are here to help. One thing that we also need to talk about laboratory security is depending on your role and depending on what you're working with, you may have had a background check. A background check is another way to indicate that we are keeping you safe. So please follow all procedures and practices within your lab from the university, your primary investigator, and the Environmental Health and Safety Department. So, our last line of defense is your personal protective equipment, better known as PPE. UCF's policies for entering the laboratory require all personnel to be wearing lab safety glasses, lab coats, closed-toed shoes, and clothing that covers the majority of their body. The purpose of this is to make sure that if a chemical is spilled, that you are not exposed to any unnecessary risk. Some types of protection that we'll talk about are eye protection, glove protection, and lab coats. So for your eye protection, we are going to ask that you wear lab safety glasses that meet an ANSI standard of Z87.1. There are different standards, and that standard could be a Z87.1 plus, but the plus is an indication of high impact. For most practices within a laboratory, we're really more concerned about your splash hazard. The way that you would identify that your lab safety glasses meets this standard is if you were to look inside along the brim, there would be some marking to indicate that it's Z87.1. Lab coats come in a variety of different shapes and forms, lengths, and types. Lab coats do need to be selected based on the work that you're being done. So if you're working with flammable solvents, a synthetic lab coat's not a great option because of the fact of when that lab coat burns, it becomes multi-material and adheres to your skin. No one wants grafted on, so make sure that you're choosing the lab coat that's appropriate for your use. If you're working in a biological lab, we're going to ask you to wear a lab coat that buttons all the way up to your neckline, so that way we minimize your exposure to pathogens. For gloves, there's different types of gloves. Some are nitrile, some are latex, some are silver shields. Different gloves have exposure times and different lengths and what they can be exposed to. There's many references out there, but if you need reference material, please reach out to the Environmental Health and Safety Department, and we'll be glad to assist you with selecting the right type of glove for the right type of use. One thing I will point out at this point is latex gloves may not be a good option for you because some people have allergic reaction to the powder that's involved with the latex. We also have particular procedures for hot and cold temperature use here at UCF. If you're working with high temperatures that create large amounts of steam, we are going to ask that you wear special thermal gloves that prevent your exposure to these hot material. Also, for steam events like use of an autoclave, we do ask you to wear a face shield on top of your safety glasses, so that way that steam condensates on the face shield and not onto your face. We don't want you to be exposed to any unnecessary risk and temperature burns. For cold temperatures, we're going to ask you to do the same thing, but you're going to wear special cold temperature gloves. We don't want your skin to be exposed to any level of frostbite or icing. And same thing with this face shield. If you're working with cryo material, we do want to make sure that there is not an exposure to a droplet of liquid nitrogen, which could expand more than 700 times its original tidal volume. If a droplet is released by a dewar, it will hit the splash shield on the mask first before going towards your face. It's just one other way that we can minimize the risk of exposure. Some labs have additional special hazards which require additional PPE. If you're working with fine particulate matter or if you're exposed to some type of airborne pathogen, we may ask you to wear a respirator. Anybody can wear a respirator. However, at UCF, to wear a respirator, you have to be medically cleared and fit to do so. Special training will include your online training, a medical clearance with a health professional, And then we'll have an actual fit test that's done annually to make sure that the mask is being properly worn. If you're not medically fit to wear a respirator, it could cause increased heart rate and exhaustion of your cardiovascular system, which could lead to medical complications. We don't want that to happen, so we want to make sure that you're fit enough to wear it by asking you to perform additional testing to do so. Also, if respirators aren't worn correctly, they won't work correctly. So if that respirator is not seated on your face, then it's not going to get a good seal and you're not filtering out the particulate matter. That is the reason why we do annual fit testing. We want to reduce your hazard and risk. Satellite accumulation areas, or SAAs, are areas in which all of your hazardous waste will be stored and properly contained. Hazardous waste must be labeled, it must be segregated, and it must be stored in the appropriate container. Secondary containment must be maintained, and that must be 110% of the largest volume within the hazardous waste area. So if we have a 1 liter jug, and that is the largest jug within the satellite area, then our secondary containment needs to hold 1.1 liters worth of volume. Labels are provided by the Environmental Health and Safety Department, and that label does need to be properly filled out. That label needs to have all of the chemicals listed and their full chemical names and the concentrations that you believe the chemicals are. If for some reason you're unable to calculate your final dilution, please always give us the initial starting dilution because we'd rather know the most hazardous, something is less hazardous than what it is. Liquid waste should be stored separate of solid waste. The container does need to be compatible for what you're putting inside of it, so putting a strong acid inside of a plastic container would most likely not be a good option. Different containers, such as gooseneck containers that have nice deep threading, are great for liquids, and other containers are more readily accessible for solids. Make sure that the container is appropriate for the hazard that you're using. Containers do need to be stored so that the container is not overfilled. We always recommend that a container be filled to about 90%. So if you were to look and start seeing the curve at the top, go ahead and stop before you get to that curve. When containers are filled and you've decided that they're no longer you're adding anything else, please make sure you put your hazardous waste request in so that way we can remove the material in a timely manner. When you create a hazardous waste label, it needs to contain the most accurate information possible. So please do not pre-fill out a label. Please fill it out only as material is added. So that way we have accurate information about what hazards are actually present within the bottle and the actual concentrations that are being mixed. Please also make sure that your hazardous waste labels contain pictograms. EHS recently changed the hazardous waste labels to contain the pictograms. So if you're looking at your hazardous waste label and it does not contain a pictogram of hazards, please request additional hazardous waste labels so that way we can make sure that you have the correct and most current version. In the event that you have to put in a hazardous waste pickup, this pickup request will be done through EHSA. Your laboratory manager or your PI will authorize that module to be added within your ESA account. Put an individual pickup request in. That pickup request will need to indicate where that waste is being stored, what that waste is, and a date in which you would like it to be picked up. Please note EHS may be able to pick up on that date, or they may go by what the scheduled date for the building is. You can find out what your scheduled pickup dates for your building and area are by checking the EHS website under the hazardous waste pickup schedule. Once a pickup request is placed in, a pickup number will be generated, and that number needs to go on the hazardous waste labels. So when a health and safety specialist arrives at your location, they can easily find your waste and know exactly what items need to be picked up. Some important reminders for hazardous waste is that hazardous waste needs to be stored in a location that prevents a reaction from occurring. So storing hazardous waste near a window where you are exposing chemicals to solar radiation would not be recommended, nor storing it next to a sink or in a sink where it could potentially go down the drain would also not be recommended. Containers do need to be in good nature and in good condition. Hazardous waste does need to be segregated and stored based on its hazard class, so flammables still need to be stored within flammable containment, and corrosives need to be stored within corrosive containment. If for some reason and you need additional guidance, For how to properly store your waste, please reach out to the Environmental Health and Safety Department and we'll be happy to assist you with that. As you fill out your labels and adhere them to the containers, please fill them out as chemicals are being added, and please give us the actual concentrations that you believe those compounds are and their chemical names. We want to make sure that if someone enters your space and is introduced to your hazardous materials and is not familiar with it, they are able to identify what those hazards are. Sharps disposals. Sharps disposal is anything in your laboratory that be considered designed to be sharp. That means razors, scalpels, and etc. Those do need to be disposed of within a sharps container. A sharps container is a red box with a closable lid. Make sure that when you remove the sharps, that you're doing so in a fashion that minimizes your risk to the bladed edge or the needle side. Make sure that when you put them in the container, they go in the container and they do not come back out. Do not remove sharps from a container and don't overfill the container. Once that container gets reasonably filled, close the lid and dispose of it appropriately. Disposal could be simply placing it with your other hazardous materials to be shipped off, or if you're in a biolab, you may be able to take that sharps box and place it within your larger bio waste box and bag those together. So another important thing to consider with sharps. Sharps are typically scalpel blades, razors, needles. Sharps are not broken glass. Broken glass needs to go inside of a broken glass box. Or you can take broken glass and put it inside of a cardboard box, tape up all the surroundings, and throw that glass away in a normal trash receptacle. Sharps is something that is actually designed and intended to be sharp. A razor blade, a needle. So please dispose of glass appropriately, and please dispose of your sharps within the appropriate sharps container. Each laboratory will have a spill kit. Please know where your spill kit is. When you first enter a laboratory area, you should always find your spill kit and assess the contents within your spill kit. These spill kits that are provided by the Environmental Health and Safety Department are spill kits that are designed to clean up 4-liter or greater spills. Any spill that is less than 4 liters, please use your standard protocols for cleaning up these spills. In the event you have a spill that is greater than 4 liters, locate your spill kit and use this spill kit to clean up the spill. I will always encourage you, before implementing any type of spill procedure, take a moment, calm yourself, and center yourself. In the event that a spill occurs, we all like to get it cleaned as quickly as possible, but keeping a calm, level-headed mind is going to be the best course of action as you go to mitigate the spill. Each spill kit that is provided by the Environmental Health and Safety Department contains a variety of different pieces of equipment to assist you in your ability to clean the spill. You'll have individual socks and berms for controlling the direction of the spill. You'll have material inside of it that is absorbent, either through pads or individual padding material, or you'll have something that's an absorbent material called stardust, which turns a liquid into a solid. There are specific types out there that neutralize different types of acids and bases. Your general spill kit does not have that. There's also a dustpan and a broom for picking up the material. There are additional bags for bagging the material as well as zip ties for closing it. You'll have an instruction sheet and an inventory list within the spill kit. In the event you need additional PPE, that will also be contained within your spill kit. That will include spill goggles as well as large rubber gloves and an apron if needed. In the event you do need to use the spill kit, it is a one-time use spill kit, so use it, bag it, label it with the appropriate hazardous material, and let the Environmental Health and Safety Department know that you've had a 4-liter or greater spill and use the spill kit to contain it. That way you can put in a waste request and have a pickup occur, and we can supply you with a new spill kit. There are additional spill kits in certain labs depending on their specialty hazards, such as mercury or hydrofluorine. Those spill kits are specific to those compounds. Please only use those spill kits for those hazards. Within the building that contains a laboratory that has specific hazards, there will be a building-based spill kit. The spill kit is designed for large bulk spills. Please know where the spill kit is, and please talk to your building manager to find out what materials are inside these spill kits. These spill kits do have tags placed on them to ensure that The contents are still within the kit, so don't open the kit unless you need to use the kit. Incident reporting. At UCF, we have three different types of incidents. We have what's known as a near miss, an accident, and an incident. A near miss is what we could better be described as an event that could have happened that could have potentially caused harm. So as I walked across my lab and I carried my chemical and I saw a banana on the ground and I missed it, that's a near miss. There was a hazard on the floor. I could have slipped on it, but I avoided it. Please report all near misses to your faculty member or supervisor so that way we can keep track of those to prevent them from occurring again. Now, an accident versus an actual incident. An accident is an event that did happen, but there wasn't significant harm or loss of life. So if I were to actually slip on the banana peel and drop the bottle, but the bottle didn't break, or I didn't get any harm to myself, that's an accident. Report this to your primary investigator or your lab manager so that way we can track these kinds of issues and hopefully resolve them through better SOPs and engineering controls. Now, if something did happen, and say I dropped that bottle, it broke, there's a major spill, the building's on fire, I significantly got hurt, that's an incident. And an incident does need to get reported not only to your primary investigator, but also to the Environmental Health and Safety Department within 24 hours of it occurring. The reason why the EHS department needs to know is because we will help you in your workplace safety practices to make sure that events like this don't happen and that you get proper medical care because you are a worker within a laboratory. So please, in the event a major incident occurs, fill out the proper documentation and let the Environmental Health and Safety Department know within 24 hours of that event occurring. So as we've talked about a little bit before, there will be additional training requirements added to your learning plan depending on your level of research and what hazard you're exposed to. You'll also have annual training requirements that must be completed, such as for this module, you're completing EHS 202. Next year, you'll have to complete an online module as well called EHS 203. As you're exposed to more research opportunities, as you're exposed to additional hazards, additional learning opportunities will be present, and we will ask that you complete these modules in a timely manner. So please keep up to date on your online training so that way you continue to move forward with your research. As a scientist, you're going to have lots of regulatory training that you're going to have to apply to through time. So this is a good practice to get in the habit of being used to that type of training. As we start to wrap down this web-based learning module, I would like to remind you that you need to complete your SDS activity sheet as well as your SOP activity sheet. Remember, your SDS is your safety data sheet and your SOP is your standard operating sheet. The material within these two activities will cover all of the guided procedures that are covered under the UCF standard operating procedures list, which includes how to read an SDS, what are some of the working hours for the university, what is chemical storage, and what do we expect with your chemical inventory. Once you've completed these activities, please go ahead and check all your boxes under the UCF standard operating procedures. Also, we will provide you with some additional guidance, including a glove guide, so that way you can compare gloves and their time linked to exposure for certain chemicals. Congratulations, you've made it through the EHS 202 online safety training course. At this point, we've covered all the material listed on the orientation safety training check sheet. Please check all these boxes, sign and date it. If you have further questions about any of these concepts or materials, please reach out to the Environmental Health and Safety Department and we'll be glad to assist you with that process and answering those questions. As we conclude, please always, 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 when you leave a lab, wash your hands and remove your lab coat and safety glasses. We want to make sure that your hazards stay within your lab and then maintain good hygiene practices.